All right, we're going to be looking at function notation, and one of the ways you're going to see this is a function is usually described as f of x. Okay, and if they ask you to find like the value of, let's say, f of 5, that 5 is replacing x, and x is just another word for input. This is something that I'm going to plug in to the function. So whatever's next to f, or whatever the function is labeled as, this in this case f of 5, that just means that's going to be my input. That's going to be something that I plug in for x. So instead of 2x plus 4, it becomes 2 times 5 plus 4. So if I'm specifically talking about a value of this function f of 5, that just means I'm taking that value they gave us and I'm plugging it in. And then I would just work that out. 2 times 5 is 10 plus 4 is 14. So the value of f of 5 is 14. So f of 5 equals 14. All right, now there's going to be different words that we use to describe these functions that mean the exact same thing. And when we talk about an x and a y, that's a domain and a range. Okay, so I've got, if I'm dealing with x and y, just understand that x is domain, a y is a range. And they'll use these words interchangeably, but x is always what I'm going to plug in. So if they're talking about a domain, they're talking about an input, something I'm going to plug in. If they're talking about the range and they say, what is the range of the function? That just means, what do I get out of that when I plug something in? What is the output? So you're going to have something you plug in, an x or a domain, and something you get out of that. That's a y, or a range value. So here they're asking for the range. They're asking for the output, and then they give me a domain. Well, a domain is just something I'm going to plug in. So this is the exact same question we just saw. The only difference is they're using different words to describe it. So they want to know the range value of f of x equals 4x plus 6. So that's the original function. Well, they're giving us the domain value of 2. So 2 becomes the number that I'm going to plug in for x. So instead of 4 times x, it becomes 4 times 2. And then the range is just the output. What did I get when I plug that in? Well, 4 times 2 is 8. 8 plus 6 is 14. So 14 is the range value. And that's what they were asking. What do you get out of it? What's the output? That's all that range is. So don't let the vocabulary confuse you on these. Now with domain, there's going to be times when you have to plug in more than one number. So here there's different ways I can represent domain. Here they want to know the range. Again, they're just asking for the output. All right, so when they ask for range, I'm going to plug some numbers in and get an answer. Well, here they show us just a little bit differently than they did before. They are giving us a value of ranges from 4 to 6, but they're using inequalities to show that. Like I could just say, what's the range of the function for the values 4 and then 5 and then 6. I could have just listed those numbers out. But a lot of times with domain, they will compare it to x, because I am talking about x. When I'm talking about domain values, I'm talking about values for x, and a common way for them to show that is to give us something like this, where they say that the x values are between, or they include the numbers 4 and 6. So if I'm talking about my x values, and that's what they're talking about here, and this is why they're using these inequalities, because x, if this was my set of numbers up here, 4, 5, and 6, my values of x are never smaller than 4. So I would say x is always bigger than, but it could also equal 4, because 4 is the smallest number. But x is going to be, 6 is my biggest number. X is always going to be less than or equal to 6. It never goes higher than 6. This is a limited domain. It only includes the numbers 4, 5, and 6. And that's how they're showing this. They're showing you that x, how does it relate to those two numbers? Well, it could equal 4, it could equal 6, but it'll never be less than 4. It'll never be more than 6. So they use inequalities. So when you see that, and this is pretty much the primary way that you're going to see that. So if you ever see a set of numbers with inequalities, just know they're just giving you a list of numbers here. They're just telling you that, my numbers are 4, 5, and 6. Now, if they give us an inequality like this and they give us multiple domains, that just means I'm going to have to plug in more than one number. So we had the function 2 times x plus 3, and they've given us these domain values. The domain values are 4, 5, and 6. Those are inputs. Those are numbers I'm going to plug in. Well, now I'm not just plugging in one number. I'm plugging in 3 numbers. So I'm going to get 3 different range values. They wanted to know the range with the inputs 4, 5, and 6. Well, I've got to plug each one of those in. And when I do that, I'm going to get 3 different answers. I'm going to plug in a 4, and then I'm going to plug in a 5, and I'm going to plug in a 6, because a domain is simply an input. It's something I'm going to plug in, and I'm going to get the outputs, the range values. So I'm going to have 3 separate range values. It is possible to have more than one range value here. So 2 times 4 is 8. 8 plus 3 is 11. 2 times 5 is 10. Plus 3 is 13. Oops, I plugged in a 5 twice. That actually should have been a 6. All right, 2 times 6 is 12. 12 plus 3 is 15. So those are my range values. What you get after you plug in the input, the domain, is your range. Okay, so I would have 3 separate answers here. Probably recognize this from the homework where they're asking you for different values. And for example, it'll say find f of negative 6. Okay, well now remember, typically with a function, it's f of x. Alright, so what this number here, we're talking about an x. If you see something here, it's an x value. And on a graph, that would be dealing with the x-axis. And the x-axis is this horizontal axis right here. So I'm going to try to find where x equals negative 6. Okay, and they want to know the value of x, or f of negative 6. That's a specific output. So remember, this is always an input. This number that they plug in right here, this is an input, and I should get something out of that. With an equation, I would just plug the number in. Well, with a graph, I'll just go up or down and figure out where do I hit that graph on the y-axis. Well, you'll notice I hit that graph at positive 3. Basically how high up did I go? I went straight up to find this graph. I went up 1, 2, 3 spaces. I went up 3. So f of negative 6 on this graph equals 3, and you can see that as the ordered pair, negative 6, 3. They actually have that ordered pair right there. Okay, so when x equals negative 6, well, what is the y value of that graph? It's positive 3. So I know that f of negative 6 equals 3, and I could do that with any value of x. Okay, so for example, if I said find f of, let's see, what's this one over here? F of 4. Okay, then I would just go over and I would figure out where does x equal 4. So 1, 2, 3, 4. X equals 4 at this specific place on the graph. Okay, and if I were to go up from there, I would just figure out, oh, how high up am I having to go before I hit that graph? 1, 2, 3, 4, 5, 6, 7. Okay, so when x equals 4, I hit the graph, the output of y equals 7. That's the range value. So the domain of 4, when I plugged in a 4, I just find 4 on the x-axis, and I'll go up or down wherever that graph happens to be. In this case, I had to go up 7 to hit that graph. So that's one way that they're going to show it. Now, they might also kind of reverse that on us and do the opposite, and I want to show you what that looks like. Right, now they might also give it to you like this, where they give you the output, but they don't give you the input. So I'm just going to basically reverse what I was doing. Okay, and I'm going to go to the y-axis this time. Now remember, the y-axis is the vertical axis here. Well, I'm not going to the x anymore because I don't know what x is. I don't know the input. All I know is where I'm going on the y-axis. Well, if I go to positive 5 on the y-axis, that's right here, and I'm going to do the opposite. Instead of going up or down, I'm on the y-axis already. I went up to 5. Now I have to go over 1, 2. So I went over 2 spaces. So when So f of 2 is where I'm going to get 5 on the y-axis. So I just had to go backwards there to figure out. If they give us the x, I'm going to go, I'm going to go over to x and figure out y. Well, this one, they're giving us the y value. I had to go over to figure out what was the x value. All right, so just figure out what they're asking you, if they're asking you for an x or a y. So this is just kind of the opposite. On the homework, I think it would say, what is the solution to f of x equals 5? Well, they're giving you the output, they're giving you the y value. Go to that place, go to that specific y value that they're talking about, and then where's the graph? Well, I had to go over 2 spaces to get there, so it was at positive 2 on the x-axis. All right, now domain and range, how I would show this if I'm asked to give the domain. Now I'm going to look at, again, domain is an x value. I'm only going to look at this x-axis, and I specifically want to look at where does this graph go on the x-axis. Now when we're showing the domain on just a number line, there was always the number line that we're familiar with where you would have an open circle or a closed circle. Well, this, if I look at the x-axis, there's a closed circle on this graph where x equals 1. If I go straight up, that's where my x value equals 1. They have a closed circle at positive 1, and they shade to the, and I would usually shade to the left. If all the values of this graph go to the left right here, and you'll notice there's an arrow that kind of points up, that means that my graph is kind of going in an upward, up to the left direction forever. It's going in that direction. So if it was on a number line, it would kind of look like this. Everything to the left is less than positive 1. So I'm going to describe the domain kind of like we did on a number line, where I'm going to say x is less than or equal to 1, because it was a closed circle right here. This circle was closed, and everything on this graph, every x value, if I'm going just horizontally, everything went to the left. So I would say x is less than or equal to positive 1. Now if I want to describe the range values though, now I'm going to go and I'm just going to look at the y values of this graph. What's the lowest point and what's the highest point? Okay, where does it go on the y-axis? Well, the lowest point of this graph is at the origin, at 0. So my range values are from 0, so y is greater than or equal to 0, because my y values never go below 0. They only go up from 0. So y is greater than or equal to 0. So that's how I would describe the range of this graph. My y values are always greater than or equal to 0. My domain values were always less than or equal to 1. So I'm just looking at, if it's range, what's the lowest place and what's the highest place. Well, this one doesn't have a highest place. It just keeps going forever. So I would say y is greater than or equal to 0. All right. Now here's a case where the graph is actually limited to a specific domain. The domain of this graph doesn't keep going forever. All right. It stops over here and it stops over here. So I'm looking at this graph and I'm going to say, all right, if we're talking about domain, I'm talking about how wide is this graph? What values does that include on the x-axis? Okay, so I'm just looking at this horizontal axis, and if I'm looking at this graph, as far as it goes to the right, it goes to positive 2. So on the right, it has a positive 2. Oops. On the right, I've got positive 2. And how far on the left I go over here, let's see, left, it goes to negative 2. So my graph is between negative 2 and positive 2. That's how wide that this graph is on the x-axis. So if I'm talking about domain and I'm talking about x is going to be in the middle. I'm comparing those two numbers, how wide my graph is, to x. And it's going to look like when we described that set of numbers earlier. X is always greater than or equal to negative 2. And x is always less than or equal to positive 2. It never goes above positive 2. It always goes to the left from positive 2, and it never goes below negative 2. It always goes to the right. And the reason that I have this inequality with the line under it is because you'll notice that the circles on this graph were closed circles. I had this closed circle here, I had a closed circle here. That's why this inequality has this line under it. Okay, it includes -2. It's always greater than or equal to -2. It's always less than or equal to +2. I'm talking about domains. I'm always going to compare it to x. Okay. Now, if I'm talking about range values of this graph, I'm just talking about how high and how low. So if I'm talking about range values here, range is just this y-axis. The highest point is up here at +2. The lowest point is -1. So just look at how high does it go? Well, it goes up to 2 and it goes down to -1. So when we're talking about range, I'm going from -1, that's the lowest place, to +2, that's the highest place. And when we're talking about range, we're always talking about y. So I'm basically going to go how low, how high. That's the limiting factor on this graph. It doesn't keep going forever in one direction. And my inequality is going to look just like it did for x. That's my lowest point, that's my highest point, and it includes this value. It actually hits the line down here at -1. Okay, so I've got -1 as a lowest point, +2 as my highest point, and that's a closed circle right there. So this is how I would describe the range. I'm just going from the lowest to the highest point. It's always talking about y values here. Y is greater than or equal to -1 because it always goes up from there. It's less than or equal to 2 because it always goes down from +2. Okay, now on domain and range, one more example real quick. I want to show you one where the domain is just greater than, where there's an open circle. So if you look at the domain of this graph, remember the domain is just the x values. Down here on the left we have an open circle at -3, and I'll always start out with the lowest domain. I've got -3, that's my lowest number. Over here at +1, that's the highest number on the graph. Domain's always talking about x, so I'll have x in the middle. So I would say my domain is greater than -3, but I will not put a line under that because you'll notice that the open circle right here is just going to be a regular less than. But over here we have a closed circle, so it's going to be less than or equal to +1. So that's what you'll expect to see when we're talking about domain and range of a function. All right, now there's a question on the homework, and you'll see this again on the test where it gives you basically two functions and they cross at a specific place. And it'll say, what is the solution to f of x equals g of x? Now when we were dealing with systems, we would give the point and we would give the x and the y. Well, here they're only asking you for the x value of where those two lines cross. So I'm going to look at where they cross only on the x-axis. And if you go over, they cross at -2 on the x-axis. So my solution would be x equals -2. That's just the x value. That's what this is asking for. If you see it asked like this, it's not asking for the y value, which would be +2. It's just asking for the x value of where those two lines cross. All right, now if you're asked to describe the domain and the range, and you're given a chart kind of like this one, and you'll see this in the homework, just remember what you're talking about when you talk about domain. Domain is always an x. So if I'm looking to represent the domain, it's going to deal with those values. My domain of this function goes from 0 to 9. So I would say if I'm talking about domain, what does that look like? Well, the lowest number was 0, the highest number was 9, and it's talking about x. Okay, so my domain values should go from 0 to 9, and domain's always an x value. If I'm talking about range, that's always a y value. So how tall is this thing? It starts at 200 and it goes all the way down to 0. Okay, so I'm going to say my range values, if I'm talking about range on this specific graph here, it goes from 0 to 200, and range is a y value, so it's always going to be related to that y value. So range, make sure you're looking at the lowest and the highest point. Your x-axis will always be your domain, so if you're asked to describe them, it's going to look something like that.